I'm going to do this session with a colleague of mine as well, Andreas Zinning. And Andreas is responsible for Trimble's track surveying and scanning business. Andreas is based here in Germany in Wiesenthal, and he formed his company back in 1993 working on technology for track surveying and measurement. So Andreas will introduce himself a little bit more. So Andreas and I are going to look at building information modeling, or BIM. And there's a lot of, if you go out on YouTube, there's a lot of information about building information modeling. It's very much the very fashionable term, very fashionable trends in the industry. I'm going to look at it, and Andreas and I are going to look at it two ways. One, we're going to provide both an American and a European or German perspective, and I think that's why Andreas and I decided to do this session together. The second thing we wanted to do is get a little bit more focused for INTERGEO and actually talk about the role of the surveyor and the geospatial professional in BIM. What is, as most of us are surveyors or geospatial professionals, we have a big important role in building information modeling, and I want to talk about that. And the context we're going to talk about this in is this beautiful design here. Now this looks like you see a lot of glossy photographs or illustrations from architectural firms. This is actually the artist rendition of the new Trimble campus in Colorado, where I work. The building on the right, in the upper part there, that is the Trimble office that I currently work in. And the building on the left is actually the creatively named building number 2, where we're going to be working, because it's our second building. And so we've actually got a nice walkway built there, because the fact that, as I discovered Sunday morning, it snows in Colorado. So as I was getting ready to board my flight to come to INTERGEO, I woke up and found 20 centimeters of snow on my porch, which meant that I missed most of Monday's meetings, unfortunately. But again, so we'll have this nice walkway. So we applied building information modeling in building our own campus. And we used multiple survey firms for the utilities, for the layout, and things like that. And Andreas and I will talk about how that's working. And to show you that it is in fact working, this is the photographs that I took on Friday, right before I left the office, to show you that the building has actually been built. So we've used building information modeling, our own tools and techniques, and we've built the building. You can also see the nasty gray clouds that produced all the snow over the weekend, so I shouldn't have been surprised. But this is, again, nice to see that building information modeling applied to our own building. So why is the industry so crazy about building information modeling right now? And I think the important thing here is, you see some of these 40% of projects are over budget, 90% of projects are late. And I think the one on the left is the most important part of that, which is the 30% of construction is rework. Could you imagine if 30% of our surveying was recapturing data that we didn't get or was corrupted the first time? I mean, the lack of productivity in surveying and mapping would plummet if we had to redo 30% of our work. But in the construction industry, it's common practice now that 30% is going to be redone. So I think there's a couple of things that can really improve this situation. The biggest thing, overall theme, is essentially virtual construction. And this is the ability to do things like clash detection, taking two systems, such as the heating system and the structural system, taking these models, combining them, and actually determining before construction begins where the clashes are going to occur, and mitigating those clashes before they occur. The second thing that can be done to reduce this rework is prefabrication. So prefabrication of materials off-site so they can be inspected before they're introduced into the building as part of the building construction process. This is a BIM, or Building Information Modeling. I'm going to use BIM from here on out, but BIM has followed an interesting evolution. If you look on the left there, 2D drawings is where many of us began. Planners, engineers, architects, all working with DXF files and transferring them around via, at one point it would have been floppy disks, and moving on to USB drives and eventually emailing DXFs around. But it's, again, it was very isolated, everybody doing their own thing, and no ability to collaborate or gain insight from each other's work. Really, the next step was just better visualization. The 3D models didn't really offer much more ability for collaboration or anything like that. It just essentially added a layer of richness, attribution to the model. But finally, over in the middle there, where we are, I'd say where we are right now, is the 3D collaboration, which is making it so that, again, the surveyors, the planners, engineers, architects, they're all working with a similar model, and they're bringing their systems together to determine, again, where things like where these clashes might occur. And again, working on ways of improving productivity and reducing that rework. The future is going to be very interesting, because you're going to then start to look at that building and the model of that building in a longer life cycle term, looking at things like time, cost, even things like environmental impact of the building over the lifespan of the building. Those are all elements which we brought into the model in the next generation. This was an interesting study that I found when I was preparing for this. This was a survey of 368 architects, engineers, and planners. And this was done in 2016 and 2017. And at that time, 50% of the projects actually had BIM being used on the project. You had about 30% of the time there was a request for using BIM as part of this. And that's now varying by country. Even within Europe, Andreas will speak a little bit about how the requirements for BIM are growing in certain areas, such as even in the German railway. I think you can touch on that, how that's actually evolving more. And what was interesting was 80% of these 368 individuals who were surveyed were able to find business value in using the BIM. There's a couple of interesting ones here. The second one down on the right, the second horizontal bar, you may not be able to read that. It says, improving ability to show younger staff how projects go together. That's a fascinating idea of being able to take repeatable processes and show them to the next generation of construction professionals. And actually, as we strive to bring younger people into this industry, the fact that they're going to be able to use building information modeling and how a building was constructed to actually look at a repeatable process that they can then improve upon, I think is really important. Again, back over on the left, all about reducing the errors that we talked about. This was an interesting study here. This is looking at BIM as a life cycle and which parts of building information modeling are providing the greatest value at the time. I think this is going to evolve over time, but right now, the area where, even across the US, UK, France, and Germany, typically it's in the design process right now where people are finding the most value in BIM. That just happens to be now. I think as we get more into prefabrication of different systems at the construction site or close to the site, I think you'll see even more BIM value further down the life cycle. But now it's mostly being realized in 2016-17 when this study was done. It's being realized in the design phase. So now, taking it back to a lot of us in the room here, how many of you would consider yourself BIM practitioners now? Okay, we can say anything we want. So, how many of you are surveyors and geospatial professionals? Okay, good. So we have the right theme here. So the rest of the presentation is all about how we participate in BIM. So we've got the right audience, we've got the right message. I think this will be fine. As I said when I presented to Trimble's Investor Relations Day, the reason why I presented first before all my colleagues was nothing gets done until the mapping and surveying professionals have come on the job site. Everything starts after us because we need to go out and determine what is on the earth, what is the condition of the assets, the infrastructure. Before it can be rebuilt, redeveloped, or built new, you have to have someone who goes out and surveys it. So while we may be in the lower right here, really that's where the whole thing begins, and then the process goes from there. If we look at some specific examples, so this is an example of an infrastructure construction project, typical infrastructure construction project. Starting at number 1, feasibility planning. Of course, airborne LiDAR, photogrammetry, UAVs, even traditional survey all play a critical role in preparing for the feasibility study before any infrastructure construction, whether it be road construction, rail construction. When you then move down into the detailed design, that's where things such as as-built surveys and increasingly as-built scanning. What is the existing structure that's perhaps going to be redeveloped? If you have 2 roads that are intersecting, or roads and a rail network that are intersecting, what does that look like now? What is the point cloud going to turn into a model of what's on the ground now? Very precisely captured so that you can then go and do the redesign. And then finally, throughout the stage 6, the execution of construction, that's an important part of this as well, where the surveyor's participating in all aspects of that. Next one up, if you look at building construction specifically, now you have more and more surveyors and geospatial professionals. And this has not typically been our comfort zone. We're coming in out of the rain and working in the buildings more often. And I think that's actually a very positive trend as well, because both surveys as how the infrastructure is going to exist, how the building's going to exist on the ground, as well as amongst its utilities. That's all an important part of this, of the planning phase. And really over in the operate and manage, as well as in the fabricate and construct stage, that's places where the surveyors are coming in and doing as-builts of the utilities as they're leading up into the building, as well as doing layout of the various systems inside the building using traditional survey instruments and then bringing in the scanning after that. Andreas is actually going to talk specifically about examples, and you'll see how these were actually used in the construction of that building that I just showed you. Very quickly, a couple of BIM concepts, and I can make these slides available to anybody who wants them, but there was a couple of things that I thought were interesting here. 2 terms that the BIM practitioners use quite a bit, which is level of development and level of accuracy. LOD 400 and 500 are some of the more advanced models used in BIM. This is when you start to get attribution about elements of the model in LOD 400. And then finally in LOD 500, this is where you have a highly accurate model of what was built, including all of the elements behind the wall, all of the elements, where they were constructed, which group constructed it, when was it constructed. So now, if you have a leak in a wall, you can actually begin to look at what plumbing system is behind that wall, when was it installed, who did it, and what elements are in there. That's very important for actually going in and maintaining the building after it's been constructed. And finally, wouldn't be a survey session if we didn't talk about the level of precision or accuracy that's required, and that varies as well. So you may actually see level of accuracy specifications 10 through 50, and you can see the precision which is required for a lot of BIM applications. This is finally moving on to the comparison between what I would call the traditional CAD model, which was the model we worked with all through 80s and 90s, and then finally the constructible model. The constructible model is a much, much richer model that allows for the prefabrication of the various components. This is where you can actually start to do the clash detection. Is the rebar and the heating ventilation system and the electrical system? Is there going to be a conflict when you start to put these in? This constructible model is a model that all of the various trade people can use to put in their elements of it, look for clashes, and then build out from there. And finally, one last slide I'm going to look at is very much the data flow, because the data flow is the most important thing for all of us in our world. We, of course, are out there capturing the real world using our survey instruments, our UAVs, our airborne systems. We're taking that data about the real world, we're putting it into BIM systems, CAD, GIS, and we're modeling the virtual world. And then the designers are coming in, modeling what the future world's going to look like, whether it be either civil applications for road or rail or building construction. And then finally, this model is then being applied, this data is being applied during the building of the civil infrastructure. It might be a 3D model that's put into a machine control system, loaded onto a dozer or a grader and actually used to build the road or the rail network. Or it's loaded into a survey instrument such as the total station here and being used to lay out all of the various components inside the building. And then finally, it's used in the ongoing GIS or facilities management system. But what's important about this is we need cloud-based collaboration tools to be able to have everybody operate with this data around the world in various time zones, in various different trades. And with that, I'm going to hand over to Andreas to talk about some very specific examples.
Good morning from my side as well. When Ron asked me to help him with preparing for the presentation, we have seen immediately that it's a huge difference between what is going on in the US and what we see here in Germany specifically, or in Europe in general. I think it's related to the education level, what we have here in our region for the surveyors, which I would say it's much more deeper, and the surveyors are much more involved. So we decided that I take it more from a European or from a German perspective and look at this in a way, what does the surveyor, what does this mean to the surveyor in future or even to today, already for today. So it starts, as Ron mentioned before, with the pre-construction. So the work is not changing that much. It's just changing in a way that much more information is collected. So instead of having very draft information in the early planning phase for the pre-construction, it goes into much more data collection using modern technology like UAVs, like laser scanning, airborne scanning. So the level of information we can provide to the designers for a feasibility study is much more than in the past. And the requirements from the community, from the people out there, if you have a new construction project coming on, especially in the infrastructure, is really to take the people with us, to talk about the project, to visualize things. And during this requirements, this information is very helpful. So the surveyor in a very early stage plays still a very important role. The next level is really about the as-built. So what we have done in the past it was some standard topographic surveys, creating a digital terrain model and then provide this to the designers. If it was related to buildings, a reconstruction of a building, you make floor plans, you make some as-built collection, provide some DXF or PDF plans. This is changing now. This is already going on. We see this that, for example, at Deutsche Bahn, when you look at the projects from Station and Service, so from stations and platforms, they request the full modeling of the as-built as the first step. So instead of just doing a standard topographic survey, it goes to massive point cloud data collection. It goes along with imagery so that the information can be visualized by the people working with this data. And it goes to a next step, and that's, in my opinion, the greatest change what we can see here. that the modeling is requested, and it's not decided yet who is doing the modeling. What we see is that the surveyors are more and more requested to do this work for the designers. Because if it's smaller design companies, they have not the resources, they have not the knowledge, they don't know exactly how to handle the data. And there's a great potential for the surveys, what we can see here. And then the last one here I want to mention for the as-built is visualization and sharing this information. So we need platforms to share this information to handle the data. And in this environment, we see the surveyor in a very, very important and unique role, because the surveyors are the only one which are capable to handle the geodetic frame. This is very, very often underestimated in the industry here, especially from the designers and the construction companies, because they don't have the background. If you think about a building project, that's quite easy to handle, because you can define a local coordinate system with scale 1, everything is easy. But if you think about a large infrastructure project where you have 100 kilometers of track build or road project, you cannot do it in the way you do it for a building. Most of the BIM software you find at the market at the moment is not capable to handle this data. So we have to think about how we can use the survey knowledge or bring the survey knowledge into these systems. This is something which is going on at the moment. It's a quite early stage, but it will be necessary for infrastructure projects to handle this. In Germany, we have the situation that we move from Gauss-Krüger to UTM, which gives us a challenge for BIM projects, because if we're in the middle, we still have a scale factor which affects our projects. In other countries, they already have taken decisions how we can address this. They split UTM in smaller sections to get rid of this. So that's something which has to be solved, and here the surveyor is a very important part of the solution here. The next one is who will host the data. So who has the knowledge to host geospatial data? And we see the surveyor definitely in an important role here. There are solutions coming which are capable to handle all relevant data in a server and give access to the responsible designers. So a good friend of mine is working for BIM for buildings, and when I talked to him about what is currently going on, he said, yeah, we come more and more in the situation that we got asked to handle the data and provide specific information for the designers. So if there's a planner for geotechnical, he wants different information than the one doing, for example, the final building design. So they handle the data, they store the data, and they just provide what is needed for the specific designers. And now the models coming in from the designers come back to this server, so that you finally get a full picture of the project and one data source. That's key here, that nobody, not three designers are working with three different data sets. The next step, going back into the field. So we have now a BIM model. Can be a BIM model of an infrastructure project, can be a BIM model of a building. And this is in any design software. So we still have a bunch of design softwares out in the field, but there's one common interface, the IFC interface, which is defined by the Smart Building or Building Summit organization. And this is supported by everyone. The only problem is you have to keep in mind that you lose information at this point. So when you go from the BIM model to the field, it's always, you have just the model. You don't have the design itself, which is behind this, so you transfer only the elements. For the surveyors, for us, as Trimble, that means we have to support this. We have to build an interface that we can bring as much as possible of this information into the field, and that the surveyors then can use the data in the most efficient way. Ron mentioned about setting out or layout in the field. So here we see the next change, and this is as well already going on, because it's no longer just bringing some corners on site for the construction people. They expect much more. So it's a mix of who's responsible for what and a mix of who has the knowledge to do what. So the effort for the surveyor on site increases by the request to do much more stakeout there. So I talked to a surveyor. She was working on a tower here in Frankfurt, and they were asked to stake out every plug. So every plug here, electrical plug, they had to stake out. And after installation, they have to control everyone. So that's the level of information, how deep the survey has to go in future. So for the utility installation, for stockpiles, so there are a lot of additional requirements coming in based on the data from the designers. The last one, that's the design to as-built verification. That becomes a little bit challenging because the tools are not really ready to do this. Of course, you can check if the corner is at the right position, that's easy, but as soon it comes to installations about from utilities, about the shapes of walls, of some other fixed installations, you start with doing high density scanning, and then you have to compare this with the as-built. That's the first thing you have to do. And you have to bring this back into the model, because what the facility manager later wants, he does not want to know if this has been built that way or that way. He wants to know how it is at the moment. So this level of detail, 500, what Ron mentioned, where you have the as-built information together with the material, with the vendor, with all these technical information behind this, that's requested at the final stage. So that's currently a field where even development is going on to automate these processes as good as possible. Beside this, from the pre-construction as built to the design and ending up at the stakeout and control, what we have additionally for the surveyor is a lot of visualization is requested. So that can be done by the designers, but very often the surveyors are asked to help with this. So visualization for several applications, not just to talk to the people in this area when there's a construction project, it's also about logistics on site. So when you plan a large site today, you have much deeper planning. You have a 3D, 4D, 5D planning, so time and money. And this goes along with visualization in which stage of the project I will have which logistic areas. Another example here is when we talk about BIM, we talk pretty much about collaboration. And there is, I think some or many of you know this HoloLens from Microsoft. And this is a very interesting collaboration tool. So we had in February, during a VDV seminar in Berlin, we presented this as an example how you can utilize this technology for a real project. So this was a station from Deutsche Bahn, where the surveyor has done the as-built survey. They have done the modeling for the designer. The designer created the new plan or the new design for the modified station. And then we played a game how designers and planners can talk about this model by sharing this just as a hologram. So both had this HoloLens wearing, and then everybody could walk around the scene and can discuss about details. And you have not be at the same location. So one can be in Frankfurt, the other one in Berlin, but you look at the same model, you see the dot, the laser dot, where you're looking at, and the other one see exactly where you're looking at. So it's a very new form of collaboration, which is really interesting. And we see the surveyor important here because he provides the data to enable this. Another example is about mixed reality. So that's what the HoloLens currently is. It's a tool which works inside. because of the light situation, it's a little bit limited to use it outside. So mixed reality or augmented reality, what we see here as an example is you have the reality seen through your telephone or camera from your telephone, and then the software running on this shows you objects here from the design. So you can go out in the field, you have this in front of you, and what you can now activate here is a layer just showing the installations or showing the design of a road. So you're really outside in the field and you see immediately what will happen at this specific position here. And that makes collaboration and the acceptance of designs much more easier than it has been done or possible in the past. To summarize this, when we come back to the surveyor here in this environment, in my opinion, the surveyor here is on the right side, but he should be in the middle, because when it's about optimizing the collaboration between construction, design, and operation, it always goes through or over the surveyors. So the surveyors is really involved in every step here. To move forward in Germany, especially, or in Europe, you can say, it will be necessary to change a little bit the rules and the laws to define or to give projects to the industry. So we see a big break between design and construction from the BIM approach perspective. The Nordic countries are a little bit further here. The problem is that up to the design, you have the benefits, then you just transfer the data to the construction company and they start again with this. So we have no collaboration between the design and the construction, but this is due to the tendering process. So it's interesting times coming up, and I can only motivate everybody to get involved in this. It's a very interesting